5 tragic impacts of Hunga Tonga Eruption. The majority of the globe was caught off guard when the Hunga Tonga Ha'apai volcano in the South Pacific erupted on the afternoon of January 15, 2022. Due to the mountain's location in the Kingdom of Tonga, which is entirely underwater, few people had ever heard of it. However, the eruption was more interesting than that. It generated a massive bang that could be heard at least 700 kilometers away in Fiji. Instruments meant to keep an eye out for nuclear testing afterwards detected the identical thud all across the planet. Well, in this video, we'll be looking at 5 tragic impacts of the Hunga Tonga eruption. Sit tight and watch to the end as we unravel these mysteries you never knew before now. 5. Causing a tsunami. Unsurprisingly, Tonga's adjacent islands received the biggest impacts of the tsunami, as waves allegedly reached heights of 15 meters and numerous people perished. In the end, though, there was damage to ports in California, the US, and even 2 fatalities in Peru. Ohlendorf said at the SSA conference that it is unlikely for a volcano-generated tsunami to extend over 1,000 kilometers. She said that the island of Vanuatu, which was 2,000 kilometers distant from the explosion and was pounded by 1.4-meter surges, provided a first indication that this wasn't typical before the waves ever reached the North and South American shores. She said that at one point, while it wasn't the same as a volcanic eruption, her team attempted to compare what they were witnessing to what may occur from a big earthquake in the adjacent Tonga Trench. That way, she said, we might at least have an indicator of the wave's potential propagation. Damage reached US harbors in California, and there were even 2 fatalities in Peru. Emil Okul, a geophysicist at Northwestern University, US, said she believed that the most likely explanation for why the tsunami spread so broadly was that the blast created an atmospheric airwave that propagated outward at about the speed of the spreading tsunami, feeding its power rather than letting it dissipate. We could think of this as a tsunami of the atmosphere, she told the SSA scientists. The airwave was so powerful that its western portion sprang over Africa to the Atlantic Ocean, while its eastern portion leaped across the Americas. The 2 airwaves caused opposing direction tsunamis to finally combine once they reached the Atlantic. 4. Huge ash plume seen in space. Fortunately, there are other methods for determining an eruption's potency than counting the volume of lava. Another way to accomplish it is to measure the ash plume's height and size. And on that metric, Hunga Tonga Ha'apai was out of this world. According to instruments aboard NASA satellites, it may have risen as high as 38 kilometers. Larry Mastin of the Cascade Volcanic Observatory of the US Geological Survey in Vancouver, Washington, said at the SSA conference that's over the top of the atmosphere. He pointed out that the Mount Pinatubo plume, which was roughly 2/3 the height of the Hunga Tonga Ha'apai plume, reached a height of 35 to 40 kilometers. Once in the high atmosphere, the Hunga Tonga Ha'apai plume swelled into an umbrella cloud with a circumference of 200 kilometers in only 1 hour. Mastin said that this was quicker than the umbrella cloud from Mount Pinatubo's rate of spread, indicating that the explosion at Hunga Tonga Ha'apai was releasing around 3 times as much ash into the atmosphere as Pinatubo had. Additionally, the effects on the ecology were looked at. Although the volcano was devoid of life, features that were just 15 kilometers distant from it nevertheless supported thriving and diversified colonies of marine life. Corals, sponges, starfish, and mussels were found in pockets around these seamounts, suggesting the persistence of these marine ecosystems and providing scientists with a baseline for future recovery monitoring. It is still recovering, according to preliminary water column measurements, and some flying ash hasn't fully settled on the bottom. A thick ash coating detected in the upper water column nearby is another indicator that the volcano may still be erupting. 3. Hunga Tonga volcanic plume warmed the planet. According to a recent analysis, the Hunga Tonga volcanic eruption produced the tallest volcanic cloud since the Krakatoa eruption in 1883. Additionally, the volcano's release of water into the sky may have warmed the planet's temperature. Scientists had to investigate unusual techniques to determine the cloud's highest height, since it ascended so high. Locally disastrous, the volcanic explosion that destroyed the Polynesian island of Hunga Tonga Ha'apai has turned out to be a never-ending source of scientific discovery. In plain view of 3 weather satellites, the hitherto inconspicuous undersea volcano in a remote area of the southern Pacific Ocean erupted with unparalleled intensity. These satellites made it possible for researchers from all around the globe to see the astounding explosion in real time and analyze its aftereffects in unprecedented detail. Simon Proud, an Earth observation scientist at the STFC Rutherford Appleton Laboratory and the University of Oxford in the United Kingdom, was one of the researchers mesmerized by the mushroom of water vapor and mineral ash that shot into the sky on that tragic Sunday evening. Proud, the principal author of a recent research that examined the plume, noticed right once that the eruption at Hunga Tonga was highly unusual. For instance, temperature readings from Earth observation satellites indicated that the volcanic cloud must have ascended to a hitherto unheard of height. When the cloud was developing, we were looking at the temperature based on the satellite data, Proud said. It went through the troposphere, where the temperature decreases with height, and then it kept getting cooler, even though the atmosphere around it should have been getting warmer. By detecting the temperature of atmospheric phenomena using infrared sensors mounted on satellites and comparing the results to the surrounding atmosphere's temperature, scientists can often determine their height. Temperature decreases with altitude in the troposphere, the portion of the atmosphere closest to the surface of the planet. However, in the stratosphere, the atmospheric layer between 9 and 30 miles in height, where the ozone layer absorbs the sun's UV energy, sending temperatures higher, these laws no longer hold true. As the Hunga Tonga cloud's temperature continued to drop, Proud understood that a more creative strategy would be needed to determine the height precisely. Proud stated, "We were incredibly fortunate that we had the region covered with 3 satellites. For such a high volcano, the computation provided pretty good findings that were really accurate. Nothing has ever been this high before." Calculations showed that the Hunga Tonga cloud broke through the troposphere as well as the whole stratosphere, plateauing only at a height of 35 miles, far into the mesosphere, a cold and dry layer. The Hunga Tonga volcanic cloud is now the tallest one that has ever been seen and is perhaps the highest one in more than a century. 2. Destroyed island. The Hunga Tonga Ha'apai volcano unexpectedly erupted on January 15, 2022, in front of a country in the South Pacific with little over 104,000 people. The surrounding islands of Tonga suffered terrible effects as a result of the initial impact. A thunderous explosion reverberated across the world when poisonous ash covered Tonga Tapu's main island. The pace and intensity of the next tsunami were significantly impacted by the form of the sea floor. Deaths and damage were reported as far away as South America, and waves struck Australia, New Zealand and Japan, in addition to California, Alaska and Chile. Additionally, it cut the submerged fibre optic cables that connected Tonga to the outside world, resulting in a protracted blackout throughout the nation. Since Krakatoa's eruption in 1883, the Hunga Tonga Ha'apai volcanic outburst was the greatest ever documented. The west coasts of Tonga Tapu, Ua and Ha'apai were hit by tsunami waves up to 15 meters high that were caused by the eruption. At least 5 square kilometers were blanketed by ashfall. Little information was available from Tonga after the eruption due to the damage to internal and international underwater connections. However, residences, roads, water tanks and other infrastructure on the west coast of Tonga Tapu, the Ha'apai Island Group and Ua were found to have sustained severe damage during surveillance flights conducted by New Zealand Defence Force and the Australian Defence Force on January 17. The Tonga Prime Minister proclaimed a state of emergency on January 18, with effect from the previous day, January 17. International aid was solicited by the Tongan government and TRCS. 1. Acid rain. Sulfur dioxide and nitrogen oxide, two gases that react with water and oxygen in the atmosphere to form acid rain, have also been released by the eruption. According to Shane Cronin, a volcanologist at the University of Auckland, there will probably be acid rain surrounding Tonga for a few years to come. Tongan mainstays, including taro, maize, bananas, and garden vegetables, might be harmed by acid rain, which causes extensive agricultural damage. Food security may be jeopardized, depending on how long the eruptions persist, according to Cronin. Since the plume seems to be moving westward, Tonga may be spared some acid rain at the price of Fiji, according to satellite photos. According to the UN Office for Humanitarian Affairs, Fiji was keeping an eye on its air quality and had recommended residents to cover their home water tanks and remain indoors in case of rain. Indeed, the impact of this eruption cannot be overemphasized. The explosion was felt worldwide. That's about it for this video. Thanks for watching. Please, your likes and subscription to our channel is one way we'll know you appreciate what we're doing. Please keep it coming. We'd also like to know about your thoughts and feelings over this volcanic experience. Feel free to drop your comments below in the box provided.